Right, now for the projectile motion, we'll take a look at a second example that doesn't start on the ground. This example won't take us nearly as long. First thing, we're looking at a ball is thrown from a height of 5 feet. So now we're adding in that height, that h, at 60 feet per second, v0, so we're in feet again. Theta is 50 degrees, our angle with the horizontal. So we'll set up our two equations. X equals 60 cosine 50 times t. That's our first one. That's the horizontal. And then y equals 1/2 times negative 32 t squared plus 60 sine 50t plus 5. And we can simplify a little bit. This time the 60 sine 50 is not an exact value, so we'll keep it in there and use the 60 sine 50 as our coefficient when we go to do some of our different calculations. So those are our two equations. Now, and let's graph what's happening here. It goes up from 5 feet, comes back down. We can do a little bit better job of that. So this is starting at 5. This is our max height. So we're definitely going to need that negative b over 2a in this situation if we're trying to find that max height. And then here is where it hits the ground. So this question asks for when and where does the ball hit the ground. Also, if we were doing maximum height, which it didn't ask for, or when does it get there, you would have to do negative 60 sine 50 divided by the 2 times negative 16. Would not be able to take the values that we're getting from this part C and cut them in half anymore, because if I were to continue this down, that would be technically when it's starting on the ground, but that's not happening because we are starting at that height of 5. So I just added in the when and where does it hit the ground. We are going to need quadratic formula for this. So t is equal, well, let me write the quadratic formula first just to remind ourselves of that. Negative b plus or minus the square root b squared minus 4ac over 2a. So again, we notice that b is that 60 sine 50. We're going to plug this in the calculator anyway, plus or minus all over 2a. Got to write the 2a on the bottom there. So 2 times negative 16. All right, now I can plug this in pretty much all in one shot with the fraction tool. So let's do our alpha y equals negative 60 sine 50 plus, I will give you a hint after I do this of what you can do in the future. We want to square this whole thing. So 60 sine 50, put that in parentheses, close two parentheses, squared, minus 4 times negative 16 times 5 over, scroll out, 2 times negative 16. And that ends up giving us a negative value. So we get, and I really should have written t here instead of x. This is our time. And that's the number that I would have gotten. Oops. Sorry, I double clicked that and moved. That negative 0.105 is really what would happen if I were to extend out the graph up here. But we can't have a negative time, so that's no good. Now, since we are dividing by a negative, the one that always works here, I'm just going to go back in. I went and grabbed up that entire thing, and I'm just going to make one edit. Everything else stays the same, but I'm going to change this to a minus. The minus or subtraction is the one that will always work for this. So if you want to skip and not have to worry about doing this twice, just do the subtraction. So we get t is equal to 2.978 seconds. That's the when. And then the where does it hit the ground is when you plug that into the x equation. So we're going to do x is equal to 60 cosine 50 times 2.978. Go up and grab it since I just had it from before. So we get 114.84 feet. Just make sure, good. Now, just to show you, even though I did not ask this question, if I were to do the negative b over 2a and do alpha y equals, and do the negative 60 sine 50 on top over 2 times negative 16. I get 1.436. I don't know why that keeps happening. I apologize. This keeps jumping out of my window. If I do go up here to scroll up top and grab this, divide by 2, notice there's a slight difference there. It's not huge, but it will make a bigger difference if you were to plug those things back in. So what if I'm looking for the maximum height, using that negative b over 2a is important, and I would just recommend doing it for every single example. All right, so that wraps up our projectile motion notes. You now have a chance to start working on some practice.